In class, we have talked about chemical changes and chemical reactions and the indicators that tell us whether a chemical change may have occurred. We've also talked about balancing chemical reactions. Now it is time to talk about the different types of chemical reactions. And we will start with a composition reaction. A composition reaction occurs when two or more reactants form one product. The example that I'm going to show you is magnesium metal reacting with oxygen gas in the air to form magnesium oxide. You see this reaction quite often around the 4th of July. If you balance this reaction, you will see you have two magnesiums, one oxygen gas, and two magnesium oxides. This is a chemical reaction because we get a color change. We have a silvery magnesium metal and colorless oxygen gas, and the product is a white solid. We also have a chemical reaction because a very bright white light is observed and heat is given off from that light. However, we cannot say that a phase change was an indicator of this reaction because one of our reactants is a solid and our product is also a solid. So no new phase was observed. Because magnesium and oxygen react to form one product, this is a composition reaction. The next reaction is the opposite of a composition reaction. It is a decomposition reaction. When you have one reactant that breaks down into two or more products, that is a decomposition reaction. Here we are looking at a reaction very familiar to you soda drinkers. Every time you open up a bottle of soda, you initiate this decomposition reaction. Carbonic acid, which is dissolved in solution, will decompose into carbon dioxide and water once you open the soda. This reaction balances pretty easily. Everything has a 1 in front of it, but there are no noticeable color changes in this reaction since all the products and reactants are colorless. There's not a noticeable temperature change either. The only indication of a chemical reaction is that we have carbonic acid initially dissolved in the soda and it decomposes to make a gas and a liquid. Since one reactant breaks down to two products, this is an example of a decomposition reaction. The next reaction we will look at is a replacement reaction. In a replacement reaction, one element replaces another element to make a new compound. In our example, we will take iron oxide or rust and react it with aluminum metal to form aluminum oxide and iron. This reaction balances pretty easily, 1, 2, 2, 1. But what we really want to look at is the replacement. So you can see that aluminum and iron switch places from reactants to products. We start with iron oxide and we end up with aluminum oxide. The indicators of a chemical reaction are a color change. We have a reddish brown solid to start with, and we're going to end with a white solid. And we will see a temperature change. You're going to see sparks. And also where the two balls are hitting, you're going to feel a temperature change. However, you will not see a new phase produced because the products are all solids and the reactants are also all solids. This is a replacement reaction because aluminum replaces iron in a compound to make a new compound. Let's talk about ionic reactions or precipitation reactions. These reactions occur when two aqueous substances react to form a solid and an aqueous product. In this case, we are going to look at cobalt nitrate reacting with calcium hydroxide. Cobalt nitrate is pink and calcium hydroxide is colorless. The products are a blue solid of cobalt hydroxide and a colorless solution of calcium nitrate. The reaction looks fairly complicated, but it actually balances pretty easily. There is a 1 in front of each product and reactant. The indicators for a chemical reaction that we can see are obviously a color change. We start with a pink and colorless reactants, and we get a green and colorless product. Cannot really measure temperature change here, but we do get a phase change. We start with two aqueous reactants and we make a solid product. Because of that, we know this is an ionic or a precipitation reaction. The final type of reaction we will look at is a complete combustion reaction. This occurs when you have some type of organic substance and you burn it in the presence of oxygen. The products are always carbon dioxide, water, and energy. In this case, we're going to look at ethanol reacted with oxygen to form carbon dioxide, water, and energy. This reaction balances as follows. We have 1 ethanol, 3 oxygens, and that will get you 2 carbon dioxides and 3 H2Os. We're not going to see any color changes because all the products and reactants are colorless. However, we will definitely notice a temperature change. A combustion reaction definitely releases a lot of heat energy and light energy. We will not see the production of a new phase because oxygen is a gas and both of our products are gases, so we will not see a new phase. This is a complete combustion reaction because we have an organic substance reacting with oxygen to form CO2 and water, and in the process releasing a lot of energy. The last thing we need to talk about is the difference between complete combustion and incomplete combustion. This first example here shows complete combustion. I have a flask filled completely with oxygen gas. We have an excess of oxygen gas. You can see when I insert the splint, it glows with a nice bright white flame. There's no black soot that you can see, and the products that we are getting are just CO2 and water. This is a very efficient burning process. For incomplete combustion, which you can see here with the production of acetylene gas, there will be a shortage of oxygen to burn. So when I ignite the acetylene gas, you see a yellow or orange flame and a lot of black soot produced. During this reaction, we get a poisonous gas produced, carbon monoxide, and this is a very inefficient burning process. The easiest way to distinguish between complete and incomplete combustion is the color of the flame. A blue flame means complete combustion, a yellow or orange flame means incomplete combustion.